Okay. So this is sort of the way I like to set things up. I'm not saying that it's going to be exactly like this, but these are the questions I kind of like to ask. So on the other side there, of course, is the practice. So try that out. Have questions ready on Wednesday. Okay. Enough. Turn that light back on. Thanks, man. It's like I better get some tea in. All right. So we are getting into chapter 4 right now. I know.
Already.
No, already. Trust me, by the way, we definitely want to get through this stuff a little bit. Because the later stuff is going to be a little bit freaky. You're going to want some more time. So, what I'd like to do for chapter 4, what I do for a lot of things, is I'm going to show you why the math we do works. That does not mean that you have to do what I'm about to do ever. I'm showing you why the math we use works.
You're right.
You guys with me?
Yeah.
I always, every time, anyway, somebody in the middle of it is like, why are you doing all this shit? Just showing. So I will show you the shortcut. We'll do a problem directly with the shortcut later. I just want to show you why the math works. So let's say I give you a list of 10 data points. What you got, Jim? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. Like. And I say, find the mean. All right, we know how to do this. I'm going to show you. So what's about to happen is every time they have a different way to give data to me, I want to be able to find the two most important things about any data set. Does anybody have any idea what the two most important calculations you can make for any set of data would be?
It's pretty blurry on your screen.
Really?
It lost the focus.
Poor little thing.
Yeah.
There it goes. Hey, what did I just say? Oh, what are the two most important things to calculate for a data set? One of them should be really straightforward, the mean. And of course, the other one's got to be the standard deviation. Are you guys with me?
Yeah.
Anytime they give me data somehow, I want to see, is there a quicker way to calculate the mean and the standard deviation? Or is there a way to do it in this situation? Okay. So this is the way that we were given data in chapter 2. Right? So how would I calculate the mean from here? Can I be a little smart about it? I want to add these all up, right? But don't I have like 2 1s? Is that cool? Plus
3 twos.
3 2s plus
4
4 3s plus 1 4. Divided by
10.
10. Now, is this a very large set of data? No. So of course the old way is actually better for this right now. But then we're going to be able to use what we're talking about in case somebody gives me data that represents 10 billion data points. Do you want to do 10 billion data points this way? No. Okay, good. Good answer. All right. So start with a small data set so you can get it, you can feel it, you can see it, you can touch it, and then you talk about what we just do in the bigger sense. So the old way, I would have the answer, right? What do you get? You get 2 plus 8, 24, 2.4?
Yes.
Okay. So whatever the hell I do now, it better frickin' come out to 2.4 or we throw it all out. And then we go get a drink or whatever. Maybe it's a little too early. This is 6 o'clock somewhere. All right. So now this is going to be something new down here. And this is going to seem really weird. People are going to be like, what's wrong with the old way? I'm just going to look at them weird because I just explained what's wrong with it. So 2/10 times 1, is that cool? 0.2 times 1, you guys see that? Plus 3/10 times 2. Plus 4/10 times 3. Plus 1/10 times 4. Mathematically, have I done anything amazing? No, right? So the math is the same, it's just rearranged. Instead of dividing by 10 last, I'm divided by 10 first. Okay, I like it. It's gotta come out the same. Right, what do I get? 0.2 plus 0.6 plus 0.12, get out of there, 0.12. 1.2 plus 0.4. 0.8, 2. Is that cool? Hopefully that doesn't like amaze too many people that I got the same number. Math don't give a shit which order I do something. So what good is this? That's a really good question. All right, math boy, who gives a shit? So here's what this is going to help us with. So again, like I said, what if I had a set of data, 10 billion data points, right? I don't want to list them, right? I don't, because that would take every whiteboard on campus and then have to go to Queen Maka and continue. Yes? So I'm not going to write 10 billion data points. What I'm going to do instead is this. Let me make some different kind of data. What do I got here? 672. Yeah. What is that? You can do it, Jeff. 672. What am I trying to do right there? What was I trying to do and it was taking me too long? What has to happen with these?
1.
They have to equal to be 1. What does this mean? I have 10 billion data points, but what percentage of them are 5s? 12%. What percentage of them are 6s? 57%. You with me?
Yeah.
Maybe. So again, this represents 10 billion data points, but I'm just kind of putting them in a much better form, am I not? I don't want to write 10 billion. This is much more informative. You guys kind of with me? A little bit. So I could have written this data set like this. 0, 1, 2, 3, no 0. Try again. 1, 2, 3, 4, and this would have been 0.2, 0.3, 0.4, 0.1. Now, what did I do? And again, I didn't do that from the table. I did it, but now I'm going to look to see what can I do in the table to make what I did quicker. What did I do with each of these? What did I do here? Each row I multiplied, right? So over here I could do x times p of x. So 12%, so 0.12 times 5, 0.6. 5/7 times 6, I don't know. Is that 3.42?
Yes.
Somebody, so what I'm doing, this shit right here, we will never do. This explains why the math I'm doing right now works. All I have to do is do x times p of x and then add them all up. That's the mean. 0.03 times 7, 0.28 times 8, I don't know, is it 2.08?
It's 2.24.
What is it?
2.24.
2.4, shit, I went the wrong way. Oh, I see what I did. So then 6.47, I lost track of it. Shit. What is it? Let's see, 4.02. You guys aren't going to help me out? 4.23. 6.47, I think it is. All right.
Yeah.
Jeff can add. Go, Jeff. Can you imagine? Can you see doing this in the calculator? List 1. List 2, what would this be?
Filter.
List 1 times
Oh,
list 2.
wait,
Yeah,
list
list 1 times list 2,
Mhm.
right? So how do I get the mean? I just have to sum these up. So now I have the formula for the mean. This is the mean, which is the sum of x p of x. So there's our first little chapter 4 formula. The formula tells you when to use it. When do I use the formula that's got x and p of x in it? When they give me x and p of x. Yes?
Mhm.
So what do I still need to calculate?
Standard deviation.
Standard deviation. I love it. Okay. So what I want you to realize, a couple things. Look at this formula here. We're going to add one more column onto this in a minute, by the way, to get the standard deviation, just so you know. Look at this formula and compare, and this is the mean, right? Compare it to what the mean was before, right? These are the same formula. I always am curious if somebody out there is like, God, what the shit? What's wrong with this guy? What's on the bottom of any probability? What always goes on the bottom of a probability? The total number of things. What letter represents that? N. So on the bottom of this is this. These are the same. Right? It looks like this is missing an over n, but that has an over n in it. So it looks like, to figure out the average x, I do the x times the weights of those. Do you guys know how to calculate your average in a class like mine, where the tests are 50-something%? You would take your test average times 50% plus your quiz average times 20 whatever percent plus. Do you guys realize that? Isn't that exactly what we're doing here to figure out the average? The value times the weight plus the value times the weight plus the value times the weight. All right, maybe. I love you guys. Some of you guys are looking at me like, please make sense. Please start making sense. I am. Okay. So, keeping this kind of idea in mind, what the standard deviation used to be, let's call it variance, let's just go to variance, was this here, right? So it makes sense that what it's going to become, notice how this became x times p of x. This piece became x times p of x. So this is going to become that. The same way. I take each variance squared times the weight plus the next variance squared times the weight, right? Do you guys see that? It's the same exact thing that happened from here to here. It happens from here to here. The p of x has n on the bottom. Same formula. It's exactly the same. So what I want to do is to try to help us make these columns only need one more column. Do you notice how this would be a lot of freaking work? I gotta do each x minus the mean, and then I gotta square them, and then I gotta multiply by p of x. Okay, so what I'm gonna do is we're gonna do the most algebra yet. I know you're excited. I'm only gonna do the algebra to prove the formula, and then we don't need the algebra anymore because it's done its job. So I don't want to use that formula because it's going to require like a lot more columns. Do you guys see that? I only want one more column if possible. So in algebra class, if you saw something like this, let me pull this out. What would you probably have to do with that? Foil it. Kick ass. Do it. Simplify this. Just to help some of you guys out, what does it mean when it's squared? You got to write it twice. I will spare you my rant about how FOIL is dumb and it shouldn't exist. Unless you're interested now that I said that. Some of you guys are like, I love FOIL, but FOIL is bullshit.
Okay, what's
I want that on record.
Okay.
because all I do is take x and distribute it, and then I take mu and distribute it. FOIL is first, outer, inner, last. Do I really need that to tell me what to do? No. I hate it because the more we make stuff like FOIL, the harder we make math sound. Oh, I couldn't do this without that FOIL. Of course you could. That's why I kind of am against a lot of songs and sayings and bullshit, because it takes us away from the idea, which is relatively simple. And if that makes me sound boring, I don't give a shit, right? It's the idea that matters. And real quick, if I had this, I know, I said I wouldn't do the whole rant, but I can't stop myself. FOIL doesn't do me any good. First, last. First, middle, last. So then would it be FOIL would have to become I don't even know. No, it's just repeated distribution, right? You distribute the x, you distribute the next thing. So what are you guys getting here?
X squared minus 2.
Good. Two of these bad boys?
2 mu x plus mu squared.
All right, so that's what you should get when you FOIL that. So I still use the word because it's a verb. I verbalize the word, so what the hell? Let me stop for a minute. You guys okay with that? All right, now I'm not going to do every step, but if you want to see every step, I can show you. It's not that terrible, but it's anyway. I'm going to throw what we just got back in, right? So this is like middle work here. Let me put this back up here. Where am I at now? I got sigma squared is the sum of. Together. Is that cool? I just replaced this with what we got, right? And again, you are never going to have to do this. I'm just showing you where the formula that we use comes from. What's the first thing I get when I distribute the p of x in?
You're going to get p of x cubed.
No, come on now. Come on.
That's not it.
Please do this.
Okay.
Sorry. This is like a function,
That's
right?
like yeah.
So I can't, if I multiply by x squared, I can't get that to go inside of it. I can't. So this is just going to be x squared p of x, right? You guys with me on that? Just write that much so far, right? Here's the part I'm not going to show you right now, and if you want to see it, I can show you in the office. Or I might make it a bonus question. I think I'll make it a bonus question. Yeah. If you do all the other work, if you do this and you do this, and you remember that the mean is the sum of x p of x, all this other shit becomes that. Bam. I did have a couple students last semester do that bonus. It came out beautifully. But I'm not going to do it right here. I'm going to make it a bonus. And if you don't believe me, then do it. So if you do all this, if you do this and get all your like terms together and so forth, it becomes that. That is the formula that we're going to use for variance. Why is it better than this? Because I only need one more column. What column do I need? Cover the summation symbol. What do I need? I need a bunch of these, right? You guys see that?
Mm-hmm.
So I need a bunch of x squared p of x's. Here's how I do it. Isn't this L3, by the way? Sorry.
Yeah.
I do L1 times L3. What's x times x p of x?
That's square times.
Don't just square this. That wouldn't make any sense. That would be x squared p squared. I don't want that shit. What else could you do? You could do L1 squared times L2, and that would make x squared p of x. Mathematically, they come out the same. Of course they do. So what do I get here? What's 6 times 5?
30.
And then 0.6 would make it 3. 0.0, right? And then 6 times 3.42. Is that 20 point? Screw it, Jeff.
20.52.
Thank you. Save me from myself. 7 times 0.21. I could maybe do that.
1.47.
And then 8 times 2.24. 17.6, 17.92?
Yes.
Ha! Sorry. All right. It's my one skill, so don't, if I couldn't teach math, I don't know what I'd be doing. Holy shit. brain, nothing happened to you, please, because that's all I can do. So what do all right. I really hope this makes some sense. This formula, anything that's supposed to represent variance, you should be able to find this in it. Because isn't that the idea of that? It's how far each data point is from the mean, basically, right? On average and all that kind of stuff. Okay. But what we've done is we made it, this is the conceptual formula. This is the formula that makes more sense practically. So what do we get when we add all these up? Let me take this away. 41.91?
42.91.
Alright, I'll quit. And then minus the mean. The biggest mistake is people forget to square the mean. So let's see what that variance comes out to be. This better come out, if it comes out negative, you just stop and go back because you did something wrong, right? You can't take a square root of a negative number. We work with real numbers in statistics for the most part. It's going to be really close to 1, I think. Really? Is it?
1.04.
What is it?
1.0491.
Blah, blah, blah. And then, so now take the square root.
.0243.
So that kind of makes sense. The biggest, I want you guys to see, 57% of the data is 6. So over half of the data is all sitting at 6. It's not very spread out. The average was 6.47. So a lot of the data is really close to the mean. And then some of the data and then this gets kind of far away from the mean, which makes the standard deviation about a little over 1. On average, they get about 1 away from the mean. Okay, so let me give you this. Actually, let's do this. Before I give you this handout, anybody need to borrow a calculator? You're going to desperately need one in a minute. No? Everybody's good? Okay. Let me show you how this looks in the calculator. Oh, God. All right. So already got this here?
So for the formula, once you distribute it, it's without the middle term, yeah?
Where
The
are we?
final form at the bottom for variance? Is that the actual formula?
If you distribute this
the bottom,
and you work with it, it all comes out to be here.
and that's the final formula, right?
Yes, this is the formula for the standard,
Okay.
for the variance, yes.
Okay.
I like it. I'm going to have it on the handout too. Oh my God. Okay. All right. Sorry. I'm easily amused. So I just want to show you, we're going to recapture this whole table in the calculator just so you can see how it will help you, especially when you have a longer list. So take a minute, go into your calculator and put in list 1, put the x's, and list 2, put the p of x's while this thing warms up. Oh shit, what happened? Is that cool, right?
Yeah.
So of course you're going to make L3 become L1 times L2. You guys, because I want this to be x times p of x. So here's the x's, here's the p of x's. So if I make L3 become L1 times L2, remember, make sure you're defining the whole list, not just a part of it. We should get the same numbers we just got. And then make L4 equal to, I would make it L1 times L3, it doesn't really matter. As long as you get x squared p. So you can make it L1 times L3. See that? You get the same numbers. Or you can make it L1 squared times L2. The numbers don't change, right? Dips don't lie, numbers don't change. And then I want to sum up L3 and sum up L4, right? Is everybody with me? You guys all right? So how do I sum up L3? Anybody remember how to sum up L3? Yes. Go to list, second stat, go to math, go to sum, L3, and then I could just hit second enter and make it L4. So those are the two things we got, right? For the sum, that was the mean, and this is the part that I throw in to get the variance. Like it. Same numbers, right? Of course. Okay, so here's what I want you guys to work on. So on this sheet, one side of it is a completely worked out problem. The kind of problem you would see from me on a quiz or a test. And the other side, of course, is a blank one for you to work out. So that you can always reference the front to see what the hell I want. Okay. So I want you to work on the blank side, obviously, right now. Oh shit, I missed the whole thing. Oh well. If you're at home, we'll do another one.